In this video, we are going to be looking at how we can find the midpoint. These problems will come from our text in lesson 732. It says in lesson 731, you applied your existing algebraic tools to analyze geometric shapes on a coordinate grid. What other algebraic processes can help us to analyze shapes? And what else can be learned about geometric shapes? So we're going to focus on the midpoint by looking at this. First, we're going to start by graphing this triangle. And if you're following along on the handout from Canvas, you can go ahead and pause the video so you can graph the triangle yourself as well. All right, so now that I have it graphed, it tells me to find the coordinates of P, the midpoint of AB. So as I look at this, I need to find the point that's halfway between A and B. Now I have a couple options here, but I think what I'm going to start with is just by getting a little bit more information to figure out how far apart A and B are. So I drew my slope triangle here, if you will, and this is one strategy that we can use. And I noticed that I go up 6 over 2 to get from A to B. So one method to find the point in the middle would be to go up 3 over 1. And that would give me the midpoint. My coordinates P would be 1, 3. And then I'm going to repeat the same process to find the midpoint Q for the length BC. So instead of going over 5, I would just go over 2.5, down 3. I would just kind of cut my slope triangle in half. So this is one method to find that coordinate. Now, if I want to find the coordinate for Q, it's not quite as easy to see. I could say my coordinate for C here was 7, 0, and I went back 2.5. So I would know that that would be 4.5, and then I went up 3 from that 0, 4.5, 3. So this is one method that we can use, and it's a pretty easy method, pretty straightforward, to just kind of cut the slope triangles in half when I have it graphed. It was set up pretty nicely for me. I had the graph. It wasn't difficult to graph, but that is one method that I can use to find the midpoint. So I found the midpoint from P to Q right there. And the last part says, prove that PQ is half of AC. Also verify that PQ is parallel to AC. So if you remember when we first proved this theorem about connecting the midpoints, we said that this segment that gets connected here is half the length of the third side of the other side AC, and that it is also parallel to it. So if I want to verify that it is parallel, I'm going to say the slope of PQ. Well, that is a horizontal segment, so that slope is 0. The slope of AC is also a horizontal segment, which is 0. They have the same slope, so they are parallel. Prove that PQ is half of AC. So if I look up here, if I find the distance from P to Q, I go over 1, 2, 3.5. And then the distance from A to C I can count is 7. So I know that it is half because 3.5 is half of 7. So this is the first method for finding a midpoint. To use this method, we would graph the segment that we want to find the midpoint, draw the slope triangle, cut the slope triangle in half for rise and run to find the center between A and B. Let's look at another method. Now let's take a look at one that's not so easy to graph. This problem comes from our text. It says, Esther thinks she understands how to find the midpoint of a graph. I always look for the middle of the line segment, but what if the coordinates are not easy to graph? And then we look and we are given the segment KL. Now, I'm not going to graph this, but I think I'll draw a sketch so we can see visually what's happening here, and we'll maybe try the slope triangle method, and then we'll see if there's an alternative. So I have my segment here from K to L, and if I were to draw my slope triangle, I guess I could figure out how far it drops. Drops from 125 down to 15, so it drops 110. And it goes over, its run would be from 2 to 98, it would go over 96. So I guess I could cut that in half and find my midpoint. So half of the 110 is 55, and then half of the 96 is 48. So from point K, if I dropped down 55, that means my y-coordinate would decrease 55, and my x-coordinate would increase by 48. I can certainly do this problem this way, but it's no longer the quick, easy method that it was on the previous slide. Instead, I want to look and think mathematically, what's the number that's in the middle of 2 and 98? Because I want to find the middle of my x-coordinates. Well, we have a process for finding the number in the middle. It's called the average. So if I average my x's, I get a coordinate of 50. If I average my y's, adding up the 125 and the 15 and dividing by 2, finding the mean of these numbers, that is 140 over 2, which is 70. That gave me the same value that I got by doing this method that took me a little bit more time. So if they're not easy to graph, you may find it helpful just to average the two x coordinates and average the two y coordinates. Again, we find the average by adding the numbers together and dividing by 2. Either way, for this problem, my midpoint would be 50, 70. Since it is a coordinate, you need to have parentheses on either side with a comma in between your x and your y coordinates. So to summarize, the midpoint is the point that divides a line segment into two parts of equal length. For example, the M is the midpoint shown here. There's several different ways you can find the midpoint. One way is to figure out how much it changes using that slope triangle and add half or subtract half depending on which coordinate you're looking at, using the slope triangle that we talked about. The other method is to use the midpoint formula, which states that for any 2 points, A and B, the midpoint can be found by averaging the x's and averaging the y's. Again, your choice, which version you use, but there are a couple options for you to find the midpoint. All right, I want you to go ahead and take a minute and answer the question to find the midpoint of A. So I can see the midpoint here is going to be 5 and 11 and a half. And then take a minute and find the midpoint for segment in part B. And then for this one, again, I chose the formula, which is going to give me the coordinate 5, 3. I'll also show you the other method for this one so you can take a look at it and compare. As I look at my y coordinates, they drop from 6 to 0, so they decrease 6, and my x grew by 18. If I cut those numbers in half to find my midpoint, I would only drop down 3 and go over 9 from this original coordinate. So looking at that, I would do 6 minus 3 for my y coordinate, and then my negative 4 grew by 9. It went 9 to the right, so that would be 5. Either way, I would get the same value for my midpoint, having it be the coordinate 5, 3. Again, you can choose which method that you want. Personally, I think the formula is a little bit cleaner, but if you're a real visual learner and you don't mind drawing that graph, that's an option for you too. Thanks for watching.